Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given an array and this array contains non-zero and zero elements, and our task is to move all the zero element or all the zeros to the end without impacting the order of non-zero elements. So to better understanding this problem, let's see few examples. So in the first example, we have an array and this array contains 1, 0, 2, 0, 3 zeros. So here we can see that we have 3 zeros and 3 non-zero elements. What we have to do, we have to just move all the zeros to the end. And after moving zeros to the end, we get the output as 1, 2, 3 and 0, 0, 0. And you can see here that we have never touched the order of the non-zero elements. It means the order in which 1, 2, 3 appears in the given array is exactly same as the order in the output array. Clear? Now let's see the next example. In this example, we have 5 elements 0, 0, 1, 2, 3. And after moving all the zeros to the end, we have this output as 1, 2, 3, 0, 0. And in this output, you can see that we have never disturbed the order of the non-zero elements. Here it is 1, 2, 3, and in the output also we have 1, 2, 3. So you have to keep this in mind that you do not have to change the order of non-zero elements. You have to keep the order of non-zero elements as it is, as given in the input array. So I hope now you have a good understanding of this problem. So let's pause this video and think about an algorithm to solve this problem. Okay. I hope by now you would have written at least basic program to solve this problem. If not, then do not worry, I am here to help you. So let's first see the brute force approach to solve this problem. And the idea of brute force approach is pretty simple. Let's say we have this array and the elements of this array are 1, 0, 2, 0 and 3, 0. And our task is to move all the zeros to the end. So what we do in brute force approach, we simply traverse elements of this array from first to last, and while traversing we check for all the zero elements. It means, and whenever we see an zero element, we simply stop and start the search towards the right in search of non-zero element, and as soon as we found the non-zero element, we simply swap both the elements. This is the idea. So let's see how it works. Let's see, we have this array 1, 0, 2, 0, 3, 0. We start traversing this array, we get first element as 1, so we do not have to do anything. We move to next element and this is a 0 element. Now we have to move this 0 to the end. So what we do, we simply start traversing from next element to the last element and find the first non-zero element, and we found here that 2 is the non-zero element. So we simply replace both the elements with each other. Now we get our array as 1, 2, 0, 0, 3, 0. Then we move to next element, that is 0. Okay, again we have to move, again we have to search towards the right a non-zero element, and we found that 3 is the non-zero element. So we simply swap 0 with 3. We get our array as 1, 2, 3, 0, 0, 0. And then we move to next element and the next element and the next element. And in this case, we do not have any non-zero element present in the array after number 3. So then, and once we complete the process, we stop. And this is how we finally moved all the elements to the end. So this is the basic idea of brute force approach. Now let's see the implementation of brute force approach in the code. Now here you can see that we have a function move zeros to end, and this function is taking array as input. Inside of this function, we are running a loop from 0 to array.length. It means if there are 5 elements, we are running this loop for 5 times. And inside the outer loop, we are checking if the current element is equal to 0 or not. As soon as we find 0 element, we again going to run a loop from I plus 1 position till array.length. It means if we are finding 0 at position 1, then we are going to search non-zero element from position 2 to 5. Clear? Okay. And inside this inner loop, we are checking for non-zero element. That's why we are checking array of j is not equal to 0. As soon as we find non-zero element, we store that non-zero element in temporary variable, and then we are going to move the 0 to that position, and then we are again moving value of temporary variable to array of I. So this is how we are swapping this 0 with 2 and 2 with 0. Okay, and after swapping we are simply breaking this loop. So it means we found the non-zero element, and now we do not need to care about all the remaining elements. And this is how this function is going to work. So let's quickly dry run this function and see how it works. So we have an array, and inside of this array we have elements like 1, 0, 2, 0, 3, 0, and these are the indexes of all the elements present in the array. So when you run this code, the loop begins, and in first iteration the value of I is 0. We can see that we have non-zero element at 0th index, so we simply ignore it, and then we simply move to next iteration. Now the value of I becomes 1. At first position, at first index, we found that there is a 0 element. So what we do? We are going to traverse from next element to the last element and in search of non-zero element. So we found first non-zero element at index 2. So we simply swap 0 with 2, means 0 index with 2 index, means element of 0 index with element of second index. After swapping, we get our arrays 1, 2, 0, 0, 3, 0, and we move on to, and we break the loop and we move on to next iteration. In next iteration our I becomes 2. We found that at index 2 we have 0. Again we have to traverse array from the next index to the end, and we found the first non-zero element as 3. So we have to simply swap element at index 2 with element at index 4. After swapping we get the array like this, 1, 2, 3, 0, 0, 0, and after breaking the loop we simply move to next iteration. In next iteration our I becomes 3, and you can see at third position we have 0, so we simply have to do nothing, and then we move to next iteration. In next iteration I becomes 4. In fourth position also we have 0, we do not have to do anything. In next iteration our I becomes 5. In fifth position also we see that there is a 0, so we do not have to do anything. So this is how this piece of code is going to run, and we get the output as 1, 2, 3, 0, 0, 0, and all our zeros are now moved to the end. I hope you got it. So talking about the time complexity of this function, as you can see that we are running two loops. Our outer loop is running n times, and for each iteration of outer loop, the inner loop is also running n times. So in case of nested loops, what we do? We basically do the multiplication of both the time taken by loops. So it comes out to be big of n square. And talking about the space complexity, as we are not using any extra space other than the input array, we are simply using some variables to store the count of iteration. So the space complexity of this function comes out to be theta of 1. Clear? So far so good. So this is all about the brute force approach. But this is the quadratic order of growth. Can we do it better? Do we have any other approach to solve this problem in linear time complexity? Do one thing, just write the input array on a piece of paper, observe that input, and think about another approach to solve this problem in a linear time complexity. So I hope you have got some idea to solve this problem in linear order of growth. So now let's see the efficient approach to solve this problem. And this efficient approach is based on this observation. So let's say we have elements in an array like this: A0, A1, A2, AI-1, and the last is AI. Okay, and we assume that numbers from A0 to AI is already processed. It means we have already arranged all the zeros to the end and all the non-zero element to the beginning. And these numbers are like 1, 2, 0, 0. Right? Now what happens when we encounter new number, that is A of I? So there are two possible cases that could happen. One thing, and first one is if AI is equal to 0. So if AI is equal to 0, we do not have to do anything, we just simply ignore it. Okay? Because this A is already to the end, so we simply have to ignore it. But what happens if we get a non-zero element? So in this case, what we have to do? we have to swap this non-zero element with the count of non-zero element. Let me show you how. So here you can see that we have two non-zero elements. So the count is equal to 2. It means we have two non-zero elements. Clear? Now if we again get the non-zero element, then what we have to do? We have to swap this non-zero element with the count of non-zero element. Okay, so we are using this 2 as an index for new non-zero element. And where is the 2 index? This is the 1, this is 0, this is the 0th index, this is the 1 index, and this is the second index. So we are simply going to move this element to second index and move this 0 to this position. Simple. So this is how we are moving all the non-zero element to the beginning and moving zeros to the end. Okay, but to follow this approach, what we have to do, we have to keep one thing in mind, that we always have to keep track of count of non-zero elements in the array. This is how we get the index for new non-zero element present in the index, present in the array. Okay, so keep in mind. So if you look at this approach carefully, what we are doing exactly is, instead of moving all the zeros to the end, we are bringing all the non-zero element to the beginning of the array. And in previous approach, what we were doing, we are simply moving all these zeros element to the end. So this is the difference between the previous approach and this approach. So this is the basic idea to solve this problem. Now let's see the implementation of this efficient approach. So here you can see that we have a function move zeros to the end, and this function is taking arrays input. Okay, in the first statement we are initializing count variable to 0. It means so far we have 0 number of non-zero element. Okay, and then we are running loop from 0 to array.length, and in each iteration we are checking if particular array is non-zero or not, right? In case of 0 we are not doing anything. That's why we are checking in if statement that if the number is non-zero, then only we have to react. Okay, if we found if number is 0, then we are simply going to store the element present at index of count to temporary variable, and then storing element at present in array of I to the array of count, and then we are again storing, and then we are again moving back the value of temporary variable to array of I, and then we are incrementing count by 1. It means we have got the first non-zero element. Okay, so this is the swap logic. We have already used this in the previous approach, and then we are incrementing count by 1. So let's quickly dry run this code and see how it works. So let's say we have array like this 0 0 2 0 3 0, and these are the indexes of all the elements present in the array. The initial value of count is 0. Okay, when we run this code, our loop begins, and in first iteration value of I is 0. Okay, so we check the 0th index. This is a 0, so we simply ignore it. In next iteration I becomes 1. At first index we again got the 0, so we simply ignore it. In third iteration our I becomes 2. Now at second position we see that there is a non-zero element. So what we have to do? We simply swap this element with the count of non-zero element, and the value of count is 0. So we are going to simply swap these two elements. Okay, after swapping, our array would look like this: 2 0 0 0 3 0, and we increment the value of count by 1. It means we have one non-zero element now. It means we now have one non-zero element to the beginning of the array. In next iteration our I becomes 3. At third location we see that we have 0, so we simply ignore it. In next iteration our I becomes 4. In fourth index we see that we again found the one non-zero element, so we are going to simply swap this with this because the value of C is 1. So at first index we have 0, in fourth index we have non-zero element, so we simply swap these two numbers. Then after swapping we see that our array would look like this: 2 3 0 0 0 0, and we increment the count by 1, so it becomes 2. So now we have two non-zero element to the beginning of the array. In next iteration our I becomes 5. At fifth position we see that we have 0, so we simply ignore it. And this is how this function is going to work, and we get our output as 2 3 0 0 0, and we have successfully moved all the zeros to the end. Great. So talking about the time complexity of this function, as we have only one loop and that loop is running from 0 to array.length, it means n times. So the time complexity of this function is going to be big of n. And what about space complexity? As we are not using any extra space, that is why the space complexity of this function is going to be theta of 1, that is a constant space. So in this approach, to solve this problem, we are taking big of n time and theta of 1 constant space to solve this problem. So this is all about the efficient approach. Now, before we end this video, let's have a quick recap of what we have learned so far. So we are given a problem, and in this problem we are given an array, and this array contains non-zero elements and zero elements. Okay, and our task is to move all the zeros to the end. To solve this problem, we saw two approaches. The first approach was the brute force approach. In this approach, what we were doing, we are traversing array from first element to last element. As soon as we find zero element, we again search the array towards the right, find the first non-zero element and swap the zero with the non-zero element. And we have to follow this process in all the iteration. In this approach, the time complexity came out to be big of n square. And after this, we saw the efficient approach to solve this problem. In efficient approach, instead of moving all the zeros to the right, to the end, we are bringing all the non-zero elements to the beginning of the array. And in this approach, the time complexity came out to be big of n. So we have significantly reduced the time complexity to solve this problem from n square to big of n. So this is it for this video. Thanks for watching. See you in the next video.